Hello and welcome. My name is Matt, and this is Site Surveys, Inspections, and Progress Reporting with Drone Technology. In 2015, there were 700,000 drones sold. We see the use of drones adding value to your team across the entire project lifecycle. Perhaps one of the most important things to plan for is ensuring that you are using drone technology safely. We can really break it down to 3 steps. First, we use our drone and sensor to collect the appropriate data. Then we need to process all that data so that it's usable. Finally, we need to present out actionable insights so they can easily understand it. Upon successful completion, we'll generate and unlock your continuing professional development credit for download. So thanks for joining me. Hello and welcome. My name is Matt, and this is Site Surveys, Inspections, and Progress Reporting with Drone Technology, one of 4 courses that make up the ConTech Academy in the field curriculum for main contractors. Through this course, we'll look at how you can leverage the latest drone technology to improve your project's existing site survey, progress reporting, and inspection process. For the sake of the course, we'll use the terms unmanned aerial vehicle, or UAV, unmanned aerial systems, UAS, and drone interchangeable, even though there are literal differences among them all. We developed this course in partnership with several thought-leading construction firms and industry trade associations, so that you have the opportunity to benefit from their experience, lessons learned, and best practices. From time to time, you'll also hear from my British partner with professional tips. Upon completion of the course, you'll have a better understanding of how drone technology is being used in construction today, and what very practical steps you can take tomorrow to improve your overall project execution and performance. This course is built for main contractors and construction service providers who are looking for an introduction to drone technology and an investigation of how it can enhance existing job site programs. In this course, we will not cover the use of any specific products, but instead we'll focus on the process. After you have completed the course, if you'd like to take additional steps and investigate potential solutions, we will provide links to best-in-class industry tools that will assist you and your team. First, we'll take a look at why this course is relevant with the growth of drone technology applications. Then we'll talk through what the potential business benefits are for you and your project team. Before we get too far, we'll provide an overview of drone technology. To understand how to take practical steps in leveraging this technology in our existing programs, we'll use the Perry model that's consistent with all of the in-the-field curriculum courses. Here, we first look at what needs to be planned for, then we take a deeper look at how you execute on site survey, progress reporting, and the inspection programs with the assistance of drone technology. We'll then spend some time talking about how we report and leverage the information captured from our efforts. Finally, we'll take a look at how we take next steps to further improve our use of drone technology. At any time while you're taking the course, you'll be given access to download a wealth of supplementary materials, templates, and guides that you can use as a starting point or for reference. You can download them by clicking on the Resources tab. These resources are being shared with you from the industry thought-leading organizations that have helped us build these courses. Visit the Partners page to learn more about these companies or to reach out if you'd like to contribute to future courses. So let's get started. In this chapter, we'll look at the growth in the use of drone technology, how drones are affecting the construction industry, and then discuss the benefits of using drones on your project site. Drone use worldwide has grown strongly for several years, a sure sign that it's not just a passing technology trend. In 2015, there were 700,000 drones sold, a figure that's expected to grow 100% year over year. PricewaterhouseCoopers, one of the largest professional services firms in the world, values the global market for business services using drones at $127 billion, of which over $45 billion is attributed to infrastructure and construction. One factor leading to the growth of drone sales has been that they have gotten less and less expensive every year. According to one of our partners, a drone and inspection sensor package that used to cost 40,000 euros just 3 years ago can be purchased for nearly a third of the price today, with nearly the same specifications. Today, the primary use of drone technology in construction is to carry some form of sensor, like a camera. We'll talk about the different types of sensors later on, but what you should know is that these sensors are getting smaller and lighter every year, which means that the drone has to carry less. This is part of the reason they're becoming less expensive. In 2015, Construction Pro Network conducted a survey that found 88% of the contractors surveyed were aware of the use of drones in construction, and that 100% of those folks surveyed who had actually used drones on a project reported that use as successful. McKinsey & Company, a worldwide management consulting firm, conducted analysis on the construction industry in 2016, and they state that there were 5 major technology trends which will affect the construction industry. One of these technology trends was the use of higher definition surveying in geolocation, citing geolocation surprises as a major reason that projects are delayed and go over budget. By leveraging drone technology, we can carry high definition cameras and 3D laser scanners with global positioning information and capture survey and location information at an ever-increasing level of accuracy and speed to help us avoid these surprises. Before we get ahead of ourselves, let's take a moment to talk through what's in it for us. Construction professionals are benefiting from their use of drone technology today in many programs, including winning work, material and asset management, accounting, quality, safety, risk management, and project communication. Here's how. Some see drone technology as helping them win more business by improving relationships and confidence with their clients. The relationship is improved when they help the client better visualize what the end result of the project will be by placing the virtual design in the context of real-world existing conditions, and then are able to iterate on their proposal more collaboratively and quickly during the bid phase. And meanwhile, by demonstrating the effective use of technology, they're improving their clients' confidence that they're able to deliver. Many firms are also leveraging drone technology to capture images of their project portfolio to help market their services to future potential clients. By leveraging drone technology with sensors that can measure volumes, construction firms are also improving their ability to manage materials and assets. Some going so far as to integrate this information back into their accounting solutions. One of the Contech Academy partners who helped us in the development of this course uses volumetrics regularly on road projects where they will keep track of aggregate or fill collected during excavation. They store it nearby and then use it to backfill in holes at the end of the project. By scanning and keeping track of the amount of aggregate that they have in particular locations, they're able to better plan how much should be taken from different areas or how much needs to be ordered in supplement. Drones being used to inspect progress on work completed is improving accounting accuracy and decreasing risk of paying for work that has not yet been completed. One of the Contech Academy partners regularly captures progress of specific bodies of work, like curtain wall installation, in their project design tools, which is linked to their schedule and accounting solution. Leveraging drones to perform automated quality inspections of work or locations that have been typically difficult to inspect or time-consuming to access is improving quality performance and minimizing rework. Safety programs are another area that are providing very strong value for main contractors with drone programs, especially for performing inspections in dangerous areas. One of our partners tells us that on many projects they work on, accessibility to the site is a major issue, and it may change from one phase of construction to the next. They're using drone site images to figure out and communicate broadly to all people on site, both access and egress on the project. By automating the capture of site survey and conditions on a regular basis, we're drastically increasing the amount of site documentation we have without adding much effort or manpower. This searchable documentation is one of the best ways to minimize your risk and exposure to litigation. One of our partners recently completed renovation of a historic site and used daily site scans to document site conditions every day, including movement and care for important historical materials. Finally, the use of drone information in your daily and weekly status reports helps to improve communication and visibility into project progress, with all key stakeholders, including your project team and client. Another partner has worked on 2 projects in the Nordics, where on a daily basis, they had a drone orbit the site and capture point cloud scan of the project. This point cloud is loaded into their design software solution and used to find differences between where they should be in project progress against where they actually are. In this chapter, we looked at the growth in the use of drone technology, how drones are affecting the construction industry, and then we discussed the benefits of using drones on your project site. In this chapter, we're going to talk about some basic types of drones, discuss the types of sensors that are relevant to the surveying and inspection process, and then briefly touch base on some governing bodies and policies you should be aware of. As with any tool, there are a couple different categories of drones. The 3 most common in construction today are fixed wing, vertical takeoff and landing, and tethered. Fixed wing drones more closely resemble airplanes that we're familiar with, where they will have a runway for takeoff and landing. They have specialty uses in construction, including the inspection of large rural areas and utilities like roadways or the conditions surrounding an oil pipeline. Fixed-wing drones are best when you have extended flight times, large areas to be surveyed, or heavier payloads or sensors to carry. Most have greater complexity if flown manually, cost more, and require more serious maintenance. Vertical takeoff and landing, or VTOL drones, are, as the name suggests, able to take off and land vertically. They're the most common type of drone used in construction today. Multi-rotor helicopters are VTOL drones, and are sometimes referred to as tricopter, quadcopter, hexacopter, and octocopter, depending on how many propeller rotor blades they have. They are traditionally used on building construction and are best for tight areas in shorter duration flights due to battery restraints. Tethered drones are typically VTOL drones affixed to a ground point, often by a cord. These drones are best for surveillance, have limited range, and offer extended flight times over traditional VTOL drones. There are a wide spectrum of drones in each category. When deciding which is best for you, think about what you're trying to accomplish. Some of the variables in specification and resultantly in price will be the range, or how far they can fly, the maximum flight time, meaning battery life, their ease of use, and how much weight that they can carry. Traditionally, that'll be referred to as their payload, which in construction will be some form of a sensor. The primary purpose of a drone in construction is really to carry a sensor that captures particular information. The weight and required stability for that sensor to do its job are 2 big factors to consider when determining which drone is right for your project. In the drone business, they'll refer to the object being carried as a payload. The 4 most common in construction are cameras, LIDAR, infrared, and geolocation sensors like GPS. Cameras are considered a photogrammetry sensor and are used to capture both photos and videos. As you know from having purchased a camera to document your most recent family holiday, there's a wide range of options on the market. And when selecting a camera, the resolution is one of the most important factors. The same is true for use in construction surveying or inspections, and is part of the reason that photos, which have higher resolution, are more common than videos. Once a bunch of photos are taken of an object from different perspectives, you can use software to create a mesh or an orthomosaic 3D representation of the object. LIDAR stands for light detection and ranging, and uses light to measure distance to a point. It is sometimes referred to as laser scanning or 3D scanning. You can use it to survey and create high-resolution maps or high-density point clouds. Infrared sensors are used to measure heat or thermal output. Say you have just completed a building envelope or enclosure. You can crank the heat up and use an infrared sensor to look for leaks. One of our partners used an infrared sensor on a project that had a very large concrete pour in cold weather conditions. They used it to ensure the slab was properly covered with an insulating mat to prevent from frost. Geolocation sensors, like GPS, are used to capture the real-world geographic location of an object. Traditionally, they'll be coupled with another sensor, such as a camera, where an image of an object is captured with the camera, and the geolocation sensor will tag it with its location. They are often supplemented with ground control points to add to accuracy and aid in the stitching multiple photos together. An RTK GPS, or real-time kinematic GPS, leverages satellite-based positioning systems to help orientate the location captured. These sensors are becoming more and more common and lessen the need for ground control points. Here are some notes if you're deciding between a LIDAR sensor or a camera. The LIDAR sensor will get you the highest density point cloud, but will require a more powerful and heavier sensor. Also, the scan from the LIDAR sensor requires more computer processing time and power. The best cameras can get you within 0.1% of LIDAR point cloud density, and you are left with the added benefit of high-resolution images that can be used. In order to get started, you'll want to study up and obtain any necessary permission to pilot your drone. Check and refer to your local governing bodies to do so. This section will mention a couple of governing bodies and regulations, but is not exhaustive and should not be considered authoritative. In the United States, the Federal Aviation Authority, or FAA, is an important governing body. 3 steps you may want to take. Number 1, obtain and register your drone with the FAA. 2, have your pilots, sometimes referred to as operators, complete a knowledge test at an FAA test center. And 3, apply online for a remote pilot certificate. In the United Kingdom, pilots are accredited by the Civil Aviation Authority, or CAA. This is not an exhaustive list, but 3 steps in the UK include: 1, you have to take a 2-day ground theory course that covers both fixed-wing and VTOL drones. In 2016, this course has a 60-question multiple-choice exam at the end. 2, the pilot must prepare and submit an operation manual. And 3, there's a final flight exam that must be passed. Ensuring safe and proper operation of the drone is important. There are a number of agencies who have great resources to help you in doing so. Here are 2 more governing bodies you should be familiar with. The International Civil Aviation Organization, ICAO, is a specialized agency of the United Nations that manages the governance of the Convention on International Civil Aviation. The European Aviation Safety Agency, EASA, helps ensure safety protection of European Union citizens. In August of 2016, the FAA in the US released a regulation referred to as Part 107, which largely eased restrictions for commercial use of drones, including for the purposes of construction. The FAA has put forth some simple rules of flight. This is not an exhaustive list, but some of the regulations were similar to the following. Keep your altitude under 400 feet. As an operator, ensure you maintain a visual line of sight. Do not fly the drone directly over any non-participants or bystanders. Give way to manned aircraft. Fly in the daytime. Similar to driving any other vehicle, don't consume alcohol and fly. Don't drink and drone. Be sure to stay away from no-fly zones, including, but not limited to, airports and emergency response areas. To assist, the FAA has great mobile application to help you check that the area you're planning to fly in is safe. It's called Before You Fly, and it's by the FAA. The FAA has put forth a great deal of very helpful resources to help you become a pilot and stay safe while operating drones. Visit faa.gov for more information, including any updates. In the UK, similar regulations and process apply. The CAA has put forth a great deal of very helpful documentation as regulations and best practice procedures are updated. A good starting point is the CAA's CAP 393 document, which sets forth the order and regulations for air navigation. Within the document, Articles 166 and 167 cover unmanned aircraft. Additionally, CAA has put forth guidance for the operation of unmanned aircraft systems in UK airspace with their CAP 722 document. Be sure to visit caa.co.uk for more information and any updates. These regulations are being updated frequently. It's important that you reach out to your local governing bodies to make sure you have the appropriate permission to fly. Great, now we've covered the basics of drone technology, the types of sensors used in surveying and inspections, and very briefly some governing bodies and resources that'll help you get started in the US or the UK. In this chapter, we'll touch on what we need to plan for when integrating use of drones in our surveying and inspection process. First, we'll look at how drone technology is applicable across the project lifecycle, deciding to outsource or build an in-house drone program, setting up flight patterns, and safety with drones. We see the use of drones adding value to your team across the entire project lifecycle. At the onset of the project, during feasibility and bidding, and then in design and pre-construction, folks are using drones primarily for the capture of existing or as-is conditions. This is applicable for all construction, but especially beneficial when there is renovation work to be done. You may use this information during feasibility and bidding to improve your proposal by helping your potential client visualize what the project will be at the end, in context of real-world surrounding the proposed asset. You'll also use it to visualize potential areas of risk and demonstrate your capable use of technology, instilling confidence in the client. One of the Contact Academy partners uses drone footage in many of their proposals to clients to help explain their plan. During design and pre-construction, you'll use this information to inject real-world conditions into design and constructability conversations, including assessing and planning site logistics, like laydown. One of the Contact Academy partners has used drones in planning to simulate or rehearse the movement of a crane before it ever came out to site. During construction, where we'll spend the majority of our time in this course, you'll perform progressive scanning, looking for changes over time or deficiencies. You'll use its information for a number of applications, including tracking and communicating progress through progress photos and reports, tracking and managing material and assets by measuring things like stockpiles, performing quality and safety inspections in large remote areas or areas that aren't safe, capturing conditions that will later be hidden as part of permanent work, for example, the location of rebar or tension cables. Improve your daily work planning with up-to-date site imagery, perhaps when performing your pre-task planning or job hazard analysis. Finally, at client handover and during maintenance, you capture the as-built conditions. This may include scanned information fed back into the design model, or leveraging thermal imaging to detect leaks in the envelope of a building asset.
Hi, my name is Dave, and I'm here to bring you my top tips about using drones to conduct site surveys, inspections, and progress reports. A social license to operate, in very simple terms, speaks to how to be a good neighbour to the businesses or residences in a neighbourhood where you're working. The use of drones to survey construction progress is becoming more prevalent, and there are some basic guidelines you should follow in their use. If used properly, these key practices can contribute to and improve your broader construction efforts to be a good neighbour. So for the use and operation of drones, there are a number of best practices you should follow. Here are some. Privacy is a very real concern with the use of drones. Be thoughtful of your neighbours when setting up your flight pattern. If you can, avoid flying over their land without permission and only capture what information is necessary. With the information you do capture, keep it secure and dispose of it if and when you no longer need it. Be as transparent as possible. Proactively reach out to your neighbours to explain what you're working on, why, and how you'll be using your drone. Be willing to listen if they have concerns. For a more exhaustive list, visit the website on your screen. There's also a great opportunity to use your drone program to improve your efforts to be a good neighbour. Here are just 3 examples of how you might do this. 1. Use your drone to automate a routine check of the site perimeter for security. For example, look to make sure there's no way that a child could wander onto the site. If you have lots of lorries, or trucks as you say in the US, turning up on site, they may be transporting mud onto the roads, especially during excavation. 2. extend your drone's routine automated site survey to also fly over the roads so you can check them. People are curious and they've got some pretty great imaginations. Have you ever been asked to cut holes or place little windows in your site perimeter fencing so that the public can see what is happening? 3. Well, you can take this a step further by using aerial progress photos to help communicate to the general public what you're working on and what progress is being made.
When starting your drone program, you'll inevitably have to determine what makes sense for your organization. You'll have to discuss and decide if it makes sense to outsource the work or build an in-house program. As the use of drones has become easier, the cost of the equipment has come down, and more successful use cases are made public, we have seen more and more construction companies build their own in-house program for the primary benefit of being able to own the process. Some factors you'll want to consider when deciding what is right for your organization are liability, your resources, the cost, and then what your use and potential benefit will be. Liability is a major factor. By outsourcing drone information capture, you can lay liability off on the third party. Conversely, if you start an in-house program, you'll want to work with your insurance provider to put an upper limit on your liability. Resource restraints are another factor, both from a capacity and a capability perspective. With an in-house program, just like any other tool you leverage in construction, initially you might want to start with one or a small set of subject matter experts across the company. Some firms see that over time, drones just become another tool and each project team manages their operation. When making this decision, think about how quickly you want to scale your use of drones for particular applications across projects. Cost is always a factor to consider. You can look at outsourcing as paying a bit of a premium for an on-demand or pay-as-you-go model. With an in-house program, you'll incur large initial upfront costs for the purchase or rental of the equipment, namely the drone and the sensors, plus training and accrediting your personnel. What plays into all of these factors is what your use of the drone will be and what the potential benefit is for you and your team. If you don't use it very often, maybe just to grab some marketing footage at building completion, outsourcing may be a better option. But if you're using it more regularly or on an ad hoc basis that might be hard to predict, then having a teammate or program set up will give you the flexibility you need. If you do start a drone program, outsourced or in-house, you'll need to determine who manages the program. There definitely isn't a one-size-fits-all solution, but it seems that the team that benefits from the information gathered has historically taken control of the program. For instance, if you're using drones to survey existing conditions for design and planning, oftentimes your BIM or VDC group might take control. But if you're using it primarily for quality inspections, your project or QA team might take ownership. One of the Contact Academy partners' drone program is run by their marketing department. Another partner sees the drone program as something that naturally is run by surveyors, because they understand how to use delicate, valuable equipment and have a spatial and coordinate-oriented way of thinking already. Many construction firms have their IT departments managing the drone hardware, including setting policy for safe use and conduct, and then from project to project might have a teammate get the necessary accreditation to operate. In order to set up your flight pattern, you need to understand what information you're trying to capture. From there, you can determine how to capture it. Here are some tips. One thing that we've seen is that less and less people are actually flying their drone on construction sites. Instead, they tell the software what areas they want to cover, what output you want from the flight, i.e. what resolution of photos, and sometimes you'll tell it altitude if you need to consider obstructions like trees. The software figures everything else out, including the right camera settings, with angles and the correct amount of overlap. The overlap is the amount of shared view one photo has with another. This is very important because it enables the stitching of photos together and has a drastic impact on accuracy. Automating the flight is considered more reliable and in most cases safer. In some circumstances, it does make sense to manually pilot your drone. Maybe you want to capture a bit of extra detail with higher resolution on a particular area of work. Or maybe it's a more complex flight, like a tall vertical structure, and you want to capture photos at multiple altitudes, but not all software has this feature. Whenever you do fly manually, here are some tips. Make sure you cover everything with 2 rows of photos, i.e. 2 altitudes. Make sure your camera is at an angle, for example 45 degrees. Make sure you take a picture every 5 to 10 degrees to make sure you have enough overlap. So if you want to fly 360 degrees around the building, then that's 36 to 72 photos. When flying manually, some folks will set their camera in time-lapse mode, so it automatically takes pictures, say every 2 to 3 seconds. They do this so that they can concentrate on the flight, not on controlling the camera from the ground. Also, when framing your subject in all photos, avoid zooming in. It's better to have a wide angle and see a big area. As a rule of thumb, the best focal length for your photos is 15 to 20 millimeters, or less. If you go to 50 millimeters, you start narrowing your field of view. If you're using your drone to track and communicate progress through progress photos, automate your drone flight path to be the same every single day, week, or month. This makes it easier to identify what has changed from one flight to the next, and allows you to put together a time lapse. Perhaps one of the most important things to plan for is ensuring that you are using drone technology safely. As a starting point, you need to make sure that you're adhering to the guidelines and best practices of your local governing agency. From there, creating your own formal policy or even informal set of guidelines is important. When you do this, it's recommended that you involve your in-house safety, compliance, and IT teams in the process. A very good starting point is to take advantage of the wealth of materials provided by the FAA and CAA respectively. Here's a list of some additional considerations you may want to put in place. The list is not intended to be exhaustive. You can set out a process for developing flight and inspection plans. Include job hazard or job safety analysis, and ensure that any flights are disclosed to your client, the landowner if they are not the client, and any personnel or neighbors that will be on or near the site. Awareness is your first line of defense and safety. During your regular daily safety meetings, make sure everyone understands where and how you will be using drones. If a drone is being used that day, have specific safety checklist inspections that should be performed based on the activity being carried out. At the onset of any project leveraging drones, make sure you have the appropriate insurance policy. You may want to build company-specific certification and training guidelines for operators and spotters, above and beyond what the FAA or CAA require, of course. Develop pre-flight checklists for various types of activities and scenarios. Maintain a flight log. And use maintenance logs to make sure that all equipment proactively stays in good working order. Now that we've talked about the uses of drones across the project lifecycle, deciding to outsource or build an in-house drone program, setting up flight patterns, and safety with drones, we are ready to explore how you will execute on your use of drones. In this chapter, we'll take a look at the process of leveraging drones for site surveys, inspections, and daily reports. After all the planning, we can really break it down to 3 steps. First, we use our drone and sensor to collect the appropriate data. Then we need to process all that data so that it's usable. Finally, we need to present out actionable insights to the appropriate stakeholders so they can easily understand it. We'll cover those first 2 steps now. After we have determined what information we're going to collect in a survey or inspection, we need to follow our pre-flight procedures, including making sure everyone knows what we're doing and where we're doing it. If we're not manually piloting our drone, then we program our flight pattern and sensor. We can then perform our survey to capture our top-down digital elevation model, or set up an orbit path to get the sides of assets to create a point cloud or mesh. Finally, be sure to check the data or photos you've captured for quality.
Look, the most important thing we do on any construction site any given day is get everyone home safely and without injury. So drones represent a great opportunity to improve how we can automate and make safer the inspection of dangerous areas, such as inspection at height or the underneath of a bridge. Digging and shoring up is one of the most dangerous tasks on a construction site, especially when you are digging in an urban area and don't necessarily know what is below you. As one of the Contech Academy partners put it, my project is safer any time I don't have to put one of my teammates in a hole.
Experts estimate that almost 80% of all the time spent with reality captured data is spent extracting deliverables. Here's how you do it in 4 steps. Step 1. We need to take all the data, often photos, collected during our survey or inspection, and upload them to a content management system. Most times this is going to be cloud-enabled, so we can ensure it's accessible to all the appropriate team members, including folks in the field. Step 2. We can correct and ensure accuracy of information location on top of the GPS captured by adding ground control survey points. Step 3. We process the information to output what we're looking for. I'll share some examples with you next. Some output types and file formats are ORTHOVIEWs and digital elevation models, or DEMs. They have file format GeoTIFF. 3D point clouds with file format RC and LAS. 3D meshes with file formats OBJ, FBX, and RCM. Step 4. You can now work with the output. Maybe you incorporate the information in with your design. You may also tag additional information on top of the OrthoView, point cloud, or mesh output, and then share it with your team. For example, if you saw a problem that required attention, you might assign corrective action to be taken to someone. Here are some example outputs gathered from photos. The OrthoView and elevation map are 2D views. The OrthoView will give you the X and Y coordinate for every point, and the elevation map will give you the Z coordinate for every point. So the OrthoView mixed with the elevation map is the 2D way to access 3D information. You can get a 3D model mapping them together. However, you aren't able to see the sides of the buildings. So, if you want to see the sides, you need to use a point cloud or a mesh. The point cloud is better for you if you are going to pull the information into some design software to work with. The mesh is better when you want to visualize something. You can use this for communication whenever the aesthetics are important. Also, if you're using this information as part of a virtual reality experience, most VR softwares prefer the mesh. In this chapter, we talked about the first 2 steps in our 3-step process. First, how to collect information. Then, how to process and manage data captured in our survey and progress reporting programs. Taking the outputs from the processed drone data, we can include images in our daily or weekly progress reports to help communicate progress or simply document what occurred on site that day. We can take this information and integrate it back into our 3D design tools to aid in the design and planning processes by providing real-world context. Or we could use tools to help us view changes of one scan to the next. Sometimes this might be presented out in time-lapse, or other times analysis might be performed to identify specific changes. One of the challenges with data captured from drones is processing and managing it, and also making sure that it is presented back out to the relevant stakeholders in a format that makes sense for them. Today, experts say that only 1% of data captured by drones is actually consumed. So let's take a look at some examples of how we can use this information more effectively. Taking the outputs from the processed drone data, we can include images in our daily or weekly progress reports to help communicate progress or simply document what occurred on site that day. We can take this information and integrate it back into our 3D design tools to aid in the design and planning processes by providing real-world context. Or we could use tools to help us view changes of one scan to the next. Sometimes this might be presented out in time-lapse, or other times analysis might be performed to identify specific changes. Leveraging volumetrics, we can calculate the amount of a particular material. In this example, this tool is calculating and can track the amount of cubic yards of aggregate from excavation work that was occurring. This is helpful information when managing materials. In this chapter, we looked at the final piece of the puzzle. we looked at a couple examples of how we do something useful with the information that was captured with drones by looking at how we can incorporate progress photos and leverage reporting on volumetrics. Now that we've planned out our use of drones and looked at how to execute and report on information captured, let's talk about next steps. It's important that we're thinking about how we continuously improve. So here are some of the next uses of drones. For you and your team, incorporating the use of drones and automation in your quality inspections is a very powerful thing. When developing and executing on your inspection and test plans, think about the best way to perform your inspections, and consider when using a drone is a good option. Here are 4 examples of inspections where it makes sense to use a drone. Inspections of areas that are difficult or unsafe to inspect in person. Inspections when you benefit from the accuracy that you get from sensors. Any inspection that could be automated and performed more efficiently by programming a drone flight pattern, saving you valuable manpower and time that can be used for additional value-add activities. Finally, any inspection that needs to cover very large areas. Additionally, the use of virtual reality is becoming more and more prevalent. Leveraging images and data captured from drone scans, you can very effectively communicate design intent or your plan of execution in an immersive environment. At handover, share your as-built model information and enable the owner to leverage drone and sensor technology to improve the operation and maintenance of their asset. Take advantage of drone delivery technology and protocol in your environmental health and safety programs when non-standard first aid supplies or equipment are needed on-site or in remote areas in a hurry. For example, we have seen the application of drones for delivery of defibrillators. Many of the Contech Academy partners believe that the next evolution for drones is finding application where we can use drones to more safely perform inspections and scans of buildings in the interiors. The primary issue today is safety. One of the partners has used drones to capture scans of a large local arena, but see that the drone technology is going to evolve such that it can be operated safely in more confined spaces. Citing that there is already great investment in improving the collision avoidance capabilities of drones, and that drones will continue to get smaller and smaller, representing less of a hazard upon collision.
In this chapter, we spent a little time discussing some of the next steps of where to use drones, and also look towards their future use.
Congratulations! At this point, you've completed the Site Survey and Inspections with Drone Technology course, and you're ready to take the knowledge summary. Here you'll have 5 questions that'll touch on a number of the important topics that we covered. Upon successful completion, we'll generate and unlock your continuing professional development credit for download. After that, I encourage you to complete the remaining courses in the Field curriculum so that you can unlock the exam and become Contech Academy in the Field accredited, which you can include on your CV or resume, or even add as a badge to your LinkedIn profile. Also, don't forget to download and leverage the resources graciously provided by our industry thought-leading partners. Whether you're just getting started or are well on your way toward benefiting from drone technology, I hope this course helped provide you with some new ideas, and I challenge you to think about what the next steps are for you and your project team. So thanks again for joining me. Have a great day.